Hello, good morning. Today is day 4. We just see how to insert the mechanical template and creating the project units, how to insert the Revit families, and how to do the black layout, how to see how to create the offset, the transition. So before we are going further, I want you to take some 30 minutes in doing a small assignment. Just on the map, on the texture drawing I shared to you, you can just choose any two rooms. For example, you can choose this room and this room. Then I want you to go to systems, a terminal, and I want you to draw one air terminal for each room, one for supply air, and another one is for return air. Supply air system, and another one is for return air system. So I want you to connect this system. I want you to connect this system by using the duct. You can use the round duct. Then here at the intersection, I want you to do the offset, to make the offset in order to avoid the collision, to make the offset here. So only 30 minutes, and doing this exercise before we proceed further. Hello, Mr. Mubarak, how are you? So, as you know, since the day one we started inserting the mechanical template, we inserted the families, system families. We just yesterday we just see how to do duct routing. We created the transition. Also, we created the offset. So before we continue further, I just want you to do a small assignment. Just go to your model, insert mechanical template, and then insert the architectural model. After that, or you can go on just this open blank space, and so we had a small assignment here, just doing some review from the day one. Just go to Revit, then create a mechanical template. After creating mechanical template, go to insert the air terminals, then creating the duct routing. So it was like this one. After creating the duct routing, you have to insert the family. Set the air terminal family. Oh, I want you to insert 4 air terminal. You insert 4. Then I want you to connect these two. Connect these two. Then I want also you to connect another here too. So at this intersection here, you have to draw the You have to draw the offset. You have to draw the offset in order to avoid collision of this system. So these two you can select the supply system. These two select the supply system. And these two make them return system. So make sure all the pipes, all the ducts, you draw by using the same elevation. So just do that assignment. You will share to me. You can do it. You can do it later, and you will share to me the WhatsApp on my WhatsApp the picture. So for now, we just want to continue with our session. So just like this, you can go to air terminal, go to system, go to, after opening the Revit and inserting the mechanical template, you go to air terminal, then select the under system tab, select air terminal, just put 2 here. These two, make sure they are supply diffuser. You can see here, we select supply diffuser. Then draw another 2 for return air diffuser. Draw another here too. Then you go and connect it. These two supply air. Go and connect these two for supply air. Then you go and connect another 2 by return air. These two. So you can see here be a collection. So make it a offset like this one in order to avoid the collision. Also make sure all the ducts are on the same elevation. So that was an assignment that we just share here and do. So you can take time and practice that, and you'll share your picture on my WhatsApp. Yes, today is day 4. So let's see. Today we'll focus more on energy, like system analysis and simulation. So let's see our overview of energy analysis capabilities in Revit tools. So the capability in Revit tools in energy analysis. You can do the following in energy analysis tools on Revit. So first one is energy analysis with insight. This insight is an online tool on Revit in which you can insert your model, and it can show you the energy needed for your building. So it can advise you which system to adjust on your building. So in order to make the building more energy efficient. So let's see. This one is the first capability, energy analysis with insight. Another capability, model setup. You can set the model by using its element, for example, walls, roof, and the floors. So let's see how to do energy analysis by using the insight. So go back to your Revit. Go back to your Revit. Then here we'll use the architecture model. You remember previously we are on the mechanical template with this our ducting system. So go and open the architecture model which I shared to you before. So from my side, I can go open. You can go to open and locate it. On my side, I located it and download. So I look for it. So open and import it. Then when it's open, you can click here, the small icon, like smaller icon like a house. You can click it. It will open the 3D view. For that, you go to Analyze tab. And the Analyze tab here, you go to Project Location. There's a small icon with the world map here. So to set the location, because in energy calculation, you need to specify first the location. So click this location. You open a dialog which shows the location and site. The first one is location. Select location. Then go. You can see here. You can just show like a small icon of the house. So you can just drag and drop to the location in which your project is located. You see. So for example, you can just if you want to see other place, you can just zoom. You see the whole map. So select the location in which your project be located. So for our case, for example, we'll choose Dar es Salaam. So to just click this icon and drag to the location you need. You just click and drop and drag and drop. Then you zoom. Let's find where Dar es Salaam is. Just drag and drop up to the location. So make sure you have internet connection, because you can see it is written internet mapping service. So make sure you are connected to the internet to access this option. So to access this insight, make sure you have internet connection. Then just hold it and then drop to your location. In our case, we choose Dar es Salaam, so I drop here Dar es Salaam. So I drop it here. So after dragging the drop it to the desired location, you can see here we have a weather stations. Probably this is a weather station which will be located near your location. You can see here to show you how much distance away from your point. We have here weather location. So your weather data will come from this weather location here. So after that, you just click OK. After clicking OK, you come here to the energy optimization. Under the Analyze tab, you come to energy optimization. Then you select Create. Select this button, Create Energy Model. So you select this Create Energy Model. So the message will come saying you are about to create the energy model. This may take considerable time during the Revit will not be accessible. So what do you want to do? I say I want to create an analytical model. So you click that option. So just wait for it to create the analytical model. I've finished. You can see here your model. I've changed the color now to blue. So you can just rotate and see. So after that, you type visibility graphics. You can type VG, or you can go to under properties here. On your keyboard, you can type the letters VG or direct go to properties, then you go to visibility graphics, click edit. So under here we have to the items of the building, mostly the building envelope. So what is a building envelope? Building envelope basically is in which your building is constructed. For example, the walls, the roof, the windows. That is called a building envelope. So let's see the meaning of building envelope, because as we go on, mostly we'll use this term. We'll mostly use it. So as you can see here, for example, we can click to see more this picture. The building envelope consists of the walls, the outer wall, the inner walls, the floor. If it's a high-rise building, it can be first floor, second floor, the roof, the windows, the doors. So that all is called building envelope. So each material of the building envelope has assigned its U value. So U value will be mostly used in load calculation. Each material have its own U value. So U value is ability to the material transfer heat. Example, the heat transfer capability of the metal is different from the wood. So the heat transfer faster on the metal more than on the wood. So its U value will be different. So here you can untick the items which cannot be used in model. For example, plumbing equipment. So make sure here all our walls, windows, because we now focusing on the building envelope. So make sure the building envelope items all are checked. Make sure the floor is checked. The doors, the walls, all the walls, lamps. That is what makes the building envelope. Go to this one, analytical model category. Make sure here the analytical space is ticked. Make sure this one option is ticked. After that, go to click OK. Then we go to energy setting here. Go to energy setting here under the system, under the analyze tab, energy panel. You see there's energy setting. Click energy setting. Then on the mode, mode of calculation, we use the use building elements. So here on the analytical analysis, you have to change this value here. You have to change this value here. So here you can put at least one feet. It's analytical space resolution. You can put at least 1 feet. Here you can leave that number 6. So just come to advanced option. You click edit. The advanced option. Here you can see we have building services. Under the building services, we have different. This is HVAC system. We have central heating, radiator, converter, radiant flow. We have hot air. We have room heater. So this is for heating system. So our building, we want to use the VAV duct. So you can see here says a VAV single duct, VAV dual duct, VAV indoor package, balcony cabinet, and coil system. So basically, this is the HVAC system. So let's take a look on this system here. Some of them, let's see what is VAV single duct, what is VAV dual duct. So here, you have to maintain the required condition inside the conditioned space. Energy has to be either supplied or extracted from the conditional space. So we have different system for energy efficiency. So that one you select the single duct, the dual duct. So for single duct VAV, see what is single duct VAV? The room by using only one duct. That means in a single duct variable air volume, the air is supplied only. For example, it's called the air is supplied only by a single duct, so it is not possible to simultaneously heating or cooling space. You cannot do the two at the one time. But in a dual duct system, you can supply at one time. You can supply both heating air and cooling air on different places. So for when you come here, we'll see the layout of the single duct variable air volume system. So in variable air VAV system, the air is variable, but the temperature is constant. So the volume of the air supplied to the conditioner system varies depending on the demand of the space. So you can see here variable volume of air is supplied to each zone, and the amount of air supplied to each zone is controlled by a zone damper. So before the air, you can see here the outside air coming, the cooling coil here, the outside air coming, we have here cooling coil, then we have fan which transport the air to our space. We have zone 1 here, zone 2, zone 3. You can see here is a thermostat which send the signal, control this damper, closing and opening the damper. So these signals are sent from the indoor, depending on the demand. So if the demand is high, we supply more air. If the demand is low, this thermostat send a signal to this VAV. It closes the damper. So here there is a control damper, automatically control damper, depending on the amount. So the amount of air supplied to each zone is controlled by zone damper. You can see this one is a zone damper. The zone damper is controlled by the thermostat. So the temperature remains constant at each zone, but the volume of air is a variable. So this system VAV, it is not good in the places where the demand is a constant supply of air. For example, in big malls, crowded area where needed constant supply of air, this system is not suitable for that. So you can see here we have the returning system, which return the stale air coming here. Some of the air is exhausted, and some of the air is mixed back. Portion of the air is returned back, the mixing with the outdoor air here. So on the dual duct the advantage of this system AV is that it has a lower energy consumption, because this opening and closing depending on the demand. So when the demand is low, the supply will be lower. Also, when the demand is high, the supply will be high. So this is suitable for using in a place where there's no need for the constant supply. If the opening and closing is controlled automatically, also the consumption of the energy by the fan will be lower. So on the dual duct VAV system, basically there are two ducts. Which simultaneously can heat or cool the zone. So it is possible to do cooling and heating at one time in a dual duct. So that's why here we selecting VAV single duct. When we are try to use this material for you to understand the other system, because you can see here we have multiple systems. So for our side, let's select this single duct VAV. After that, we come here building infiltration class. So the building is not full airtight. Sometimes the portion of the supplied air is sometimes leaking through the doors or windows. So if you specify here, if you are building, you design this is a very tight, no air loss outdoors due to infiltration. So let us opt medium. There's a medium loss of conditional air to the outdoor. Then here on the building data, you select the type of your building. Building type. Building data, here we have a building type. You select. There is accommodation, dining, hotel, retail, depending on the parts of your building. So let's select office. If you are designing a hotel, come there to select hotel. Or if it's an exercise center manufacturing, select it. Let's select office. Then we go to building operating schedule. This is a time in a day in which the building will be occupied by residents. So let's consider your facility is 24/7. Maybe it's manufacturing 24/7. That means 24 hours, 7 days operation. Since assume our office operate 12 hours per day, 6 days a week. So we select 12/6 facilities. 12 is hours, 6 is days. On the HVAC system, we have a couple of different options. So as you see upward and the building services, we selected VAV single duct. So let's come here. You can see central VAV, chillers, boilers. So let's select also this central VAV. So we come here on the outdoor air information. Click edit. So basically here we put the data from the HVAC. As you remember before, we were discussing on how to do OPR. So this data we can find it on HVAC 62.1. So this data depending on the type of the space you select of the building type. We select office. So you can just go to your browser. You can just type HVAC 62.1 video only. So you click the first link. Find the HVAC 62.1. This one is standard for ventilation in the acceptable indoor air quality. So we want to see which value to put here. So when you open it, it will ask you to put some of your information. Just accept. So let's go to the table. Minimum table 6.1, minimum ventilation rate. So let's find the office require how much CFM amount of outdoor air required. So let's find here, look for the office. You can see here there's a different types, motels. So when you go to office buildings, you can see here we have 5. For break rooms is 5. You can see CFM is 5. And the area is CFM per foot square is 0.12. So we want to select this office space. We select 5 CFM, and the area of outdoor we select this 0.06 CFM per feet square. So here is 5 CFM. Then outdoor air per area. .06 CFM per square feet. So you can click, if you have the data for air change, you can click and put it. So for us this data to 2 items is enough. You can click OK. Then we come here, which we select rooms. So we come to this section, conceptual type. come here to define our building envelope. So for exterior wall, just click that drop down menu and see there is a high insulation. There is a typical cold climate, typical mildy climate insulation. So let's select typically. Depending on the region which you living. So let's select lightweight construction, no insulation for our exterior wall. If you use the high mass construction on your wall, let's assume our building, our exterior wall will be lightweight construction and no insulation. On the mass interior wall, so only one option. On the mass exterior wall underground, we have this 3 option here. Select it, no insulation, high mass, no insulation. Under roof, let's selecting typically insulation, dark roof, the mass flow, lightweight construction, the slab. Let's select that option. Okay. On the mass glazing, this is made for the door, for the windows. If your window is single pan or double pan, so let's select this double pan fitted. The mass skylight, mass shade, let's select basic shade. So here basically you define your building envelope. Then you click OK. So that you come to building schematic. You can see here for roofs, we are going to assign the U values. For roof, just click it. If your roof is wood or it is a slab, find it to see, because in our model our roof is a slab. On top of our roof, will be mounting the air handling unit. So let's find the heavyweight slab. So let's select heavyweight concrete, 6-inch heavyweight concrete with 4 insulation. Under exterior walls, basically you select which type of material you need to make your exterior walls. Then select the standard wall construction. Under interior walls, the light plaster brick, light plaster. So let's select this one, the best one. Light plaster brick, light plaster. So on the ceiling, this underground walls, no need, you can leave it. Our building it's not have underground. So for ceilings, you select the material for ceiling. You have 8-inch lightweight concrete. For example, you have let's select this 1/2-inch plaster with TG boards. On the floor, let's select this tile floor. Slab. Let's select the standard slab. Then the doors, we use wood. Let's select wooden. Exteriors windows, interior windows. So let's select for glazing, domestic, and the interior windows. The same as above, the double glazing, domestic. Okay, then you click OK. Then after that, we click OK. You click OK second time. Then you save. Ask you to save. Yes, say save. So wait for it to save. So then after that you come to before this was energy setting, how to edit the energy setting. So before moving to the next to see how to start the simulation, let's say there are some few minutes for break, 5 minutes, then we'll continue. So for now we check this. We come analyze, then we set the location of the project, and then we created the energy model. Then we come here to set energy setting. So now let's go here, generating analytical model. So you just click here, generate. It will appear this message, and then we click update energy analytical model. Then you click OK. After that, you come here to optimize. You click optimize. It will open here your account, Autodesk account. So you can see now here it's analyzing in process. Is this one? So you can see here analyzing in progress. So let it analyze and finish. Also, when you go to your email address, you will see the notification from Autodesk. Tells that you have just uploaded the model. When the model completed analysis, you will be notified. So when you go to your inbox, you will see that message notification. So wait it. So when you upload in the inside, finish to analyze the model. You can see here, this is the model we inserted. Just click it. After the model analysis finish, you will receive an email from Autodesk. So let's move it. You can see here the location. I click location. You can see here our location which we selected before. So the system is analyzing depending on the location. So here you can see the result, your analysis. Here we have the cost for each cubic square meter for 1 year. So generally, the current setting for this building will cost this amount of estimation in this amount of dollars meter square area here. So let's go and see the suggested option. You can see here the suggested option. Let's go to check it one by one. So here you can see the building orientation. So here it suggest which building orientation would be good. Also, building orientation affects the amount of heat from the sun is dissipated. So here, this is our when we come to here, you see this is our setting, current setting on our model, on the 0. So this is a suggestion. You can see when you go to the right hand, the value decreases. So you just drag this. So when you rotate your building to this, maybe to here, you can move it up to here, 90 degrees from the current position. You will save this amount of cost, 0.17 USD per meter square. So let's optimize the low setting. Then we will go close. This one is about the building orientation. The building orientation also affecting the amount of solar energy hitting the building. So here you can see there is 1,000 volts. How to adjust the 1,000 volts? Here we have the shades shading on the window. So you can see shade can reduce HVAC energy use. The impact depends on other factors, window size. So you can see here no significant change. But leave it. Let's go back. Window glass size. You can see here our setting from the original model. No significant change. You can leave it. 1,000 volts. Also here no significant change. So you can go for each option and then optimize according to the result. Now let's go to HVAC. We go to HVAC to see the suggested system used for this building. You can see here, if we choose to use, you can see here as the model it is 0. So the suggestions from the inside system suggest us to use a HVAC pump terminal. When you use this system, will reduce the cost. So let's drag it. You can see here the suggested system to use and impact on the cost. So for example, here the suggestion is to use a HVAC terminal heat pump. When you use this system, will make the cost will decrease. For example, when we selected to use just drag VAV, you will see the cost will be high, $15 USD per meter square. So if you select maybe then this, so we can optimize. We can optimize according to the inside result. So here, HVAC heat pump terminal will give us a significantly low operation cost. And there's this HVAC system for this building. Also, you can also see here high efficiency VAV, not bad. So you can also opt for high efficiency VAV. So we can choose between these three, because you can see it's good cost for each floor, each square area per year. So you can choose between and see which one suitable for you according to it costs per floor per year. So over here, our operating scheduling, show the setting for operating scheduling. Our setting is here. So if the building is usually to 12 hours per 5 days, the cost will decrease by $1. If using 24/7, the cost will increase by $6 meter square per year. So this one you can leave at our setting here. You can drag and leave at our setting. Here PV panel suggestion, if you want to use the PV panel for renewable energy. So here suggest you, if you use PV panel, you can save significant small. You can see here you can decrease by 0.24 if you choose high efficiency panel. So this is just an option for use renewable energy. So if you don't plan to use, you can just ignore this option for PV. If you plan to use a PV system, you can just consider to check this option. So that is how to optimize the building using Insight. Hello. I just want to repeat this section again here with the guys, how to insert this architecture model, to analyze the system, to create the model for to analyze it in the Insight and the Revit. So open the Revit, you go here to file, then you open the model which I shared to you on your WhatsApp. You open that file. So you come here, file, and you go opening. You can see here, then you open. Now opening it, level 3 model like this one. Then you go here to location. The location, make sure the internet mapping service is selected. That, yeah, On the other side, you'll have a small map, the icon, house icon. So you just drag and drop this icon to the desired location in which your project will be constructed. So here we choose the Salam. So after choosing location, you click OK. After that, you come to energy optimization here. Come to energy optimization, there is an icon, click and create energy model. You just click it. Then you create energy model. When the energy model created, you can see here also the icon change now. Now become delete energy model. So when you see the icon change here, means by the energy model created. So after that, come to set the energy parameters here, energy setting. Come to this icon. Here, use building element. Then here, the ground plane is level 1. Phase, you select new construction. Phase 2, existing and new construction. So under here analytical space subresolution, you can leave with the default value. On the mode, you use building element. Use building element. Okay. The first one, use building element. Here you select the level 1. And the second phase, use alright element visible. So this one don't use only element visible in this current model. You stick this one. You tick this one, you can see the phase construction become faint. The ground plane, select level 1. Just leave here the default value, then come to here advanced other option. Click edit. So here you can select simple with shading surface.
Detail the model, target percentage grading.
And a silver space tolerance.
We have simple shading. Yeah, that's the first one. Simple shading surface. Then silver space tolerance.
Then you come to building envelope, use function parameters. Then you come to building services. Here you can see we have a couple of options, different air system. Central heating, this is for heating system. These heaters are for heating system. Then we came to VAV, single duct. Then you come to building infiltration class. If the building is tight, no air, no loss air to the loss indoor air to the outside, you can click that. If there is a small loss, you can click medium. If there is a higher loss of indoor air, you can click loss. So let's choose medium. Yeah, under building type. Selected office. If multiple depending on the building. Under operating schedule, the time in which the building will be occupied. This one is time with day of the week. So let's assume our office will be occupied 12 hours a day for 6 days in a week. Then we come here to VAC systems. There's a central VAV. There's a different system here. So since we selected up VAV, let's use central VAV. Chiller boilers, high efficiency. Then how to do air information. To get this information, go to Ashrai 62.1. Yes, select central VAV, HW heat, hot water heat, chiller. Then how to do air information. This information you can get from Ashrai 62.1/6-1. You can just here see frame depending on your building type. For residential or for retail, you can see here hotspots. So we selected for office space. This one, the office building. We select office space 5 CFM. And also the CFM per feet is 0.06. You can see here
It's 5.
0.06. No air person as partial for office space is 5 CFM. 5 CFM. CFM per square feet 0.06. Area is 0.3.
Area is 0.3, 0.6, 0.6.
So you can use it. Yeah, information. You can use only this two item. Window air in the area per air per area from our data. Then use the outdoor air and FM. So click OK. So here export category. You want to export the data to the inside electric room. So if you created the spaces, for example, if you create certain number of spaces on your model, you can click spaces. So let's just click the rooms, check the whole building. Then go to conceptual types.
Material thermal properties or rooms.
Under material properties, you go to conceptual types. So here you define the material, the building envelope. So basically all the data here you'll get from approved architectural drawings. So let's consider this exterior wall is lightweight construction, no insulation. Then interior wall.
No, on the first ones, lightweight construction typical independent installation. Okay. Second, massive wall. Lightweight.
Also here we select lightweight construction,
No
insulation.
Mass exterior wall underground.
So this one you can leave it because in our model we don't have an underground wall. Go to mass roof. Let's select it. Let's select the no insulation dark roof. No insulation.
Mass roof. Yes, mass roof. Material for that.
Now we go to mass flow. Select lightweight construction, no insulation. Also on mass slab.
Lightweight construction.
So basically this data will get from the construction drawing from the architect. Will provide all of this data for building building envelope. So just now let's consider we have the lightweight construction. There's a floor as no insulation. Then on the slab also, let's consider high mass construction, no insulation. Then grazing, select the double pane tinted.
Double pane.
So let's select again double pane, clear, no coating. The shade, let's select basic shade. Mass opening, let's select air. Then select OK. So that we come to schematic types. Click. There are 3 dots here. Just click. So here you put the information for the U value of the building envelope. So let's start here with the roof. This is a construction information will be available on the approved construction drawings. So let's assume we use 6 inches. Heavyweight.
Starting with the first.
Let's use our building. You can see is a flat roof. select this one, flat roof. The exterior walls,
Are there 6 lightweight instead?
here you scroll up on the roof here. You just scroll up until you see flat roof.
Flat roof.
So basically, this information will be shared to you by the architect and the
Okay.
approved drawing for constructions. So in case of this building, let's choose 6 inches.
Where are you finding external wall?
Let's choose we are on the roof. So let's assume we use 6 inches concrete. Let's assume our roof is heavy concrete slab.
Okay.
This is a 2-inch insulation. If you on your drawing, the architecture uses a flat roof, so you select flat roof. So let's use 6 inch.
No, on the roof.
On the exterior walls, select the standard wall construction. The interior walls, select light plaster, brick, light plaster. Then coming to underground walls, just untick it because on a building don't have. You have the underground walls on your design architecture drawing. It is approved for construction. You can select, you can tick it. If you don't have underground wall, and then on the ceilings, ceilings you come here and you select select the 1/2-inch plaster, STG boards, the 16 joints in the center.
Slow.
There's a U value of 0.2 BTU hour square Fahrenheit. Then on the ceiling you select 1/2-inch plaster, these boards. Then you come to floor, you select passive floor, no insulation tile or vinyl. There's a U value of this one. You come to slab, we select standard slab. The door,
standard describe construction. Standard describe. Which one is it? A and B. Okay. A and B. Yeah,
The door, you select the wooden. If you use a metal door in your design, architectural design, you select metal door. Because metal door have a higher U value, conducting more heat, as it is more heat conductive than the wooden. So depending on the type of material used, for our case, let's assume we use wooden doors. An exterior window.
Standard describe. Passive flow expression is in passive. Yes.
Exterior windows. Select double glazing, domestic.
Which one is best?
Double glazing, domestic.
The difference is what best means.
Select just the first one, double glazing, domestic.
0.6. Yeah. Double glaze. Yes. Yes, but there's a front of the starting from the 0.6, 0.6.
So we come to interior window. So here basically let's assume this is our building. Let's assume this is our building. Here we have the rooms. So this is the walls which are exposed to the sun. About the exterior walls, like here, this is the building envelope. This is walls which are not exposed to the sun, they call the interior walls. So if they have the doors and the windows, you can see here there is interior walls. So means the walls which are inside, not exposed to the sun. So also if you have windows, they call the exterior windows here. Here it's called the interior windows. So we just feed here the information for the building envelope. Interior window, you can select same as the exterior window. You just kindly select. Let's select this large double glazed windows. That you finish.
Double glazed. Which one? Double glazed.
Let's select this large double glazed window, reflective coating. Then you select OK. That you click OK. So here you can see the information. If you click this link here, it will guide you on how the setting affects the energy analysis. So if you click this link here, it will open the Revit. It is explained how each setting affects. So after that, we click OK. Then we click OK. Let's click Save. It will take some time to load. So after finishing the editing the energy setting, you come to generate here. We are still under Analyze tab. Energy optimizations. Next step, we click generate. So after setting up the building envelope parameters, we come to next step, which is generate, located on the Analyze tab under the Energy Optimization palette. Click here, generate. Then this dialog will appear here. Click Update Energy Analysis Model. Then you click OK. Clicking OK, we come same area and the Analyze tab. Here we have under energy optimization palette, we have this one, Optimize. So if you not using before this option, become the accept the terms and conditions. Then accept the terms and condition. We come here to optimize. Click optimize. It will direct you to the Autodesk website. So it will open the browser and it will go to your Autodesk account. You can see here we're starting analyzing the cloud. So make sure you have internet connection. Also, when you just open inside, Revit will send you the email to tell you that we've just uploaded the model. We're waiting for result. When result completed, you receive another email to access your result. So this stage can take some couple of minutes. You need to wait. So wait until this process completed, then you will continue. So I selected level 1. I selected level 1 because when you come to our model on the floor plan here, and there's a project browser in the floor plan. You can see level 1 is the ground level. If you go to section view, you can see if you go to create a section view here, go to view, you can see that level one is our ground level. So that's why there we selected the level 1 is our ground level. Because here it is written ground level plane. We selected level 1 because it is our ground level. So now it has finished. You can see here this is our model. Now it is finished analyzing. You click it. After it finished analyzing, you click it. Here you can see you can just rotate to see the building. Then here on the location, you click it. It will show you the location which you assigned before. So just go down, scroll down. So just scroll down. Here you will see the benchmark comparison. CD meter square for 1 year. You can see just the system analyzes that will use 22.6 USD. So here you can optimize. You can optimize your building. In order to minimize this value, Revit will give you the suggestion. So here you can get the history if you just imported the model many times, the same model. It can give you the history of the model depending on the way you just in the parameters. So here the first option say building orientation. Say rotate the building clockwise from 0 degree. 90 degree rotates north side of the building. So our current setting, you can see here 180. So basically you can see here there's a sunrise from this side. So our narrow side of the building need to be facing sun. So here Revit suggestion for our building. We are in the middle here. This is our building setting. So it give us suggestion. Rotate our building 90 degree here. We will increase we will decrease the cost of the energy on our building by 0.68 USD. So just hold this. So here you'll see here the value decrease. So you go to another option in the adjusting. So and adjust the parameters here. You can see here we have parameter for the building material. So here it shows the ratio for the window to the walls. Our setting, current setting on your building it's good. So here no need to change it. You can leave it easy. So you go to another one, window shades. You can see no effect on our building. This is our state on our building, current state. Don't know if you can see difference. You go another one. You go each option one by one. So here you can see our building condition is here. It is good. Don't need to change it. So just scroll down. Actually make sure you adjust. If there is a significant change, adjust. So one is from there, it's about the building envelope. All this is about the building envelope. Let's come to down here. You can see here it shows the lighting efficiency. Current setting now. Our current setting now is this one. So you can see here the significant differences. So here we can adjust suggestion here is to use 3.23 watt per meter square. So this one is for rating our lighting equipment. If you choose the one with high watts per meter square, the cost will be increasing. So choose this one, 3.23 watt per meter square, lighting efficiency. When we choose our lighting equipment, so make sure we choose this one or the following, the second one. So let's go to HVAC. Here is our setting. As you can see, we need to optimize our system up to here. And now to show which HVAC system to use. You can optimize up to here. So if you choose from this one up to this one, you can reduce the cost per meter square per year. So this one is high efficiency heat pump. This is one is a high efficiency packaging terminal AC. High efficiency packaging system. This is a Chirac packaging terminal. So if you choose this high efficiency VIV, let's choose the high efficiency VIV. So it will significantly reduce the energy costs. So for this two, if you plan to use the PV solar, show the suggestions for the solar. Here are the operation schedule, the time at which the building will be occupied. So our setting is here. You can see here if the building is full occupied 24/7, the cost will be high. So in terms, it is manufacturing facility. Sometimes need to operate 24/7, but our system is an office. It's selected before 12 hours per day, 6 days per week. So we occupy 12 hours per day for 5 days. We'll reduce, but let's stick at this one. So here you can tweak if you want to use the renewable energy PV solar. You can see the suggestion. If you don't plan to use the PV on your building, you can just leave it. So that is how to insert the model and optimize the model for energy efficiency by using the Insight, the cloud-based tool on Revit. So I'll take a short break now. So let's continue here. So let's continue here on how to see different scenario. So when you click here, building, go back, clicking this building form. After adjust the settings, and you see, and you decrease this value. energy value, consumption value for the area meter square one for 1 year. Go to this again here, building form. Then go back to inside here. Then go back to inside. Then let's do comparison between our setting and this is a scenario for net zero. So this as a goals, millennium goals, net zero, millennium goals for energy. We have net zero in architecture, 13. So if we customize our model net zero, you can select here. You will start optimizing your model to net zero. So waiting for results. So after selecting the net zero scenario, you can see here the building now optimizing it to 7 USD 0.99 per meter square per year. So let's click it, see what will be changed.
I don't have this.
So when you go to net zero, you can see here what changed is for on the renewable energy system, this PV panel. So you can see here, you need to use 90% of your roof coverage. Need to be use 90% coverage of your roof area. Putting solar panels. Payback period 30 years. So the net zero basically on the use of clean energies. So net zero basically on the use of clean energies. When you go back to inside, let's test another scenario. Architectural 2030. So after
hapa kwa mpaka hapo tulipofikia.
so let's see here, architecture 2030.
Kwenye road wanasipandia na hivi au bado ni kwa analysis ya hii. Kwa kukompea na 0 na ya model yenyewe.
So you can see how the 2030 actual tools. We go to linear orientation, you can see now set it at 45 degrees. The window ratio is set now at 15%. Window shade nose. You can see. So you see air infiltration now change it to 1.6 air change power. The lighting you can see now between 11, 7.5. So this is how to compare different scenario. 0 image in the architecture 2030 with our model.
Hello.
Shalom, yes, hello, I'm hearing you.
This the final stage I did, the modeling Autodesk Insights.
Yes.
My own is not working. He said I should contact my customer care or something.
So can you show me the screenshot on my WhatsApp number?
Yes, I'll send you a screenshot.
Okay.
Yes.
Okay, now let's see. Now let's see how to calculate the heating load by using the Revit. Before we See, before we are checking how to do the simulation, energy simulation, and see how we can minimize the cost for the energy per meter square per year. So let's go back to Revit. You can see this is our analytical model. The analytical model we created before. So you can go here under the Analyze tab. And Analyze tab, on the Analyze tab you go to System Analysis. The System Analysis, after you click System Analysis, a pop-up menu will show up with a two workflow. So you have to select the workflow. You go to Analyze tab, then you go to System Analysis. On the energy optimization, you go to System Analysis. And then you click System Analysis. You see the two options. So it will ask you to select analysis workflow. So we have two workflow. First one is annual billing energy simulation, and the second one is HVAC system load and sizing. So what's the difference between these two? This is the first one. If you have only the architecture model without then the MEP systems, you can use this first option. So if you have already created for the second workflow, if you have already created the drawing with the all MEP system, select the second option. For example, now we just created the energy simulation. We used the architecture model. So let's see each one how it works. Let's start with the first one, annual building in energy simulation. So after that, you click Run Analysis. Here we'll see the system analysis. It's calculating at the background. So waiting the background process to finish. So it's continuing now, analyzing in the background. It can take some time. So let's wait it until it finish. So we are still waiting for it to finish. You can see here it's still running. So waiting for analysis calculation to finish. So you can see now the background process completed for the heating load calculation. So just go to the project browser. Go to project browser. Then go to report. Go to reports. Then click analysis report. Click then open. So you can see here our report. We have the 27% cooling, interior equipment, lighting 10%. So you can click here and see the table, consumption, electricity consumption, and cooling. You can see here the consumption. This is energy use. So here you can see the cooling load. The cooling load here. Is 300 kBTU. So this value depending on the if you set in pico unit or metric unit. So we have 3,223,981 kBTU. We have interior equipment here. When you see here electricity view table consumption. So here you can see monthly consumption of electricity. You can see the first one is annual overview, monthly overview. You can see here the cooling consumption for January. It is million BTU per month. So it shows you this is the design months from January to December. Here you can see the total value in million BTU. You come here, you see cooling consumption, and you can see electrical demand. So you can see here cooling peak demand. So if you encounter the error, it will show you where the error located, and here's the report. The program name is Energy Plus, which usually for our energy simulation and the heating load, cooling load analysis calculation. This is a version of the software used. We selected the office building. You can see here our location, and this is weather data, user station, the time of simulation here. You can see here annual billing facility. You can see here site and source of energy per total building area located here. Here is the building area. The net condition area, you can see all the area conditioned. So the end users, the lighting, interior equipment. So if you are configuring and the model and setting the mechanical equipment, so it will be appearing here. The data will be appearing here. So this is a detailed report. You can see here, this is a detailed report. So if you want to export, just go to File, Export, create PDF file. Can come here. look for our report.
Ni kama hivyo sasa. Sana tu huyu hapa ni anaonyesha